Let's solve 3x squared plus 5x equals 6. So the thing to notice that's different about this one is there's a number other than 1 in front of x squared. Now that number in front of x squared is 3. And it's called the coefficient. Again, it's the quadratic coefficient. So the idea would be to divide both sides by 3, because we'd like to get rid of that 3 in front of the x squared. This is not how to do it. So when you divide, you have to divide the entire left side by 3. Right now, it looks like somebody's just trying to divide the first term by 3. But what about the 5x? Right, so you have to divide the entire left side by 3. So instead you do this. Okay, so it's got to be the original entire left side, 3x squared plus 5x, all over a 3, equals 6 over 3. On the left side, we happen to have 3x squared plus 5x over 3. So I'm just looking at the expression on the left side of the equation and asking, do the 3's cancel? Well, they don't, because of the plus sign in the numerator. Right, so we have 3x squared plus 5x. So the 3 in the numerator is not a factor. You can't cancel as written. So what do? We're actually going to, on the next slide, you'll see we will rewrite the left side. Instead of 3x squared plus 5x over 3, we'll split that up as two separate fractions. 3x squared over 3 plus 5x over 3, using the fraction addition rule. It's just sort of in the reverse direction that we normally use it. So here we go. Take the equation here, divide both sides by 3. Since the 3's don't cancel as written, we split this up as two separate fractions. Now the plus sign is no longer in the fraction. So in 3x squared over 3, the 3's do cancel, and so we're left with x squared plus 5/3 x equals 2. So you'll notice one little change here is that the x that was in the numerator up here is now just written kind of off to the side, but that's still numerator stuff. Now we have now that we have that the coefficient of x squared is 1, there's just a hidden 1 in front of x squared, we can now apply the completing square process. So linear coefficient 5/3, half of that is going to be the second stick, so 5/3 divided by 2. In other words, 5/3 divided by 2 over 1. Or let's change division to multiplying by reciprocal, 5/3 times 1/2. So 5/6, that is the second stick. And then take the number 5/6, and we need to square it, right? Take the second stick. If you square the number, that's going to be the constant. We apply one of the two formulas boxed in the upper right. You get 25 over 36. So that's the number we add to both sides, 25/36. Okay, and then the left side is going to factor as x plus second stick squared. You should check. On the right side, I will maybe not bother through all the details here, but we should end up with 77 over 36. And then when you square root both sides, you'll have x plus 5/6 is equal to plus or minus, and then the radical of with the fraction inside, using the formula highlighted in red in the upper right, becomes root 77 over root 36. You can simplify the root 36 as just a plain 6. And then one last thing to solve for x, we just need to subtract 5/6 on both sides, and I just combine this all into one fraction since they had a common denominator. So here's the point, is there's a strategy we can apply when the coefficient of x squared is not 1. So when completing the square, before examining the linear coefficient and the second stick and all that kind of stuff, first make sure that there isn't some additional number in front of the x squared, like a 3. We want there to only be a hidden 1 in front. So to do that, you first divide both sides by the quadratic coefficient and then use fraction rules. So in our last example, 3x squared plus 5x equals 6. We divided both sides by 3, used a fraction rule, and then, after writing the left side as two separate fractions, then finally the 3's canceled. And now that the coefficient in front of x squared is a hidden 1, we could then compute the second stick from the linear coefficient. Okay, just to remark, because it was sort of done quickly, previous slide, was that 5x over 3 can become 5/3 x. You should work through some of the work on that. We'll do this in just a second. The reason we wrote it as 5/3 x is because it's a lot easier to spot the linear coefficient being 5/3, because remember that that's the number next to x, but not including x. So let's just real quick say, why is 5x over 3 really equal to 5/3 x? Well, if you start with 5/3 x, this does not mean notation for distribute the x on top and bottom. Okay, this really means 5/3 times x, or in other words, 5 over 3 times x over 1. And for multiplying fractions, you multiply straight across. So you have 5 times x over 3 times 1, which is really 5x over 3. So if you read that in reverse, 5x over 3 is 5/3 x. Okay, let's solve this equation, x squared plus 2x equals 15. We don't have to worry this time about a number besides 1 in front of the x squared, so it's just a hidden 1 in front of the x squared. Here's what we can do. So we'll complete the square. Notice the linear coefficient is 2, right? 2 is the number in front of x. Divide by 2 to get the second stick. So in this case, the second stick is 1. Now remember, we have to take the number 1 and square it to get the constant. Now 1 squared happens to be 1, but you'll notice that the second stick 1, you have to square that number to get the constant. So the constant isn't copying the second stick. It never was. It's just we got a coincidental situation here where when you square 1, it just happens to be 1 again. So we need to add 1 to both sides. You have x squared plus 2x plus 1 equals 16. The left side should be something squared, so it's x plus second stick squared equals 16. Square root both sides, and you have x plus 1 is equal to plus or minus 4. Subtract 1 on both sides. So you get x is equal to negative 1 plus or minus 4. Now this can be your final answer, but since the numbers are so nice, we can work out negative 1 plus 4 is positive 3, and negative 1 minus 4 is negative 5. So you could write x equals 3 or x equals negative 5. So that could also be your final answer. Let's do this problem in an entirely different way. If you start again with the question at the top, x squared plus 2x equals 15. I would like to start by subtracting 15 on both sides. So there's a 0 on the right side. Then the left side, we get lucky, happens to factor as x minus 3, x plus 5. Apply the zero product property. So you get x minus 3 equals 0 or x plus 5 equals 0. And then when you solve the little equations, you get x equals 3 or x equals negative 5. So you get the same final two x values either way. But I think because factoring was possible once we had, remember you have to have a 0 on one side, that was faster, to be really honest. In fact, in our second answer, we even spent the work of rewriting the original equation. So actually answer number 2 is shorter even by one more line in some sense. So we should probably save time from completing the square. The thing is, let's just complete the square when factoring doesn't seem to work. Because factoring, if what you have factors, will probably be faster. So let's compare the strategies that we have then for solving a quadratic equation. If possible, I think the thing to do is to try to add or subtract terms on both sides until one side says 0. Then on the other side that doesn't say 0, on the other side factor if possible, and then apply the zero product property. But if factoring seems impossible, then complete the square. So first, if there's a constant on the side with the x squared and the x, maybe you want to add or subtract that constant away first, like some of the first examples we saw. Then, if the coefficient in front of x squared is not 1, so you've got like a 3x squared or a 7x squared or whatever, then divide that on both sides, and apply your fraction rules. And then once the coefficient of x squared is 1, so there's just a hidden 1 in front of the x squared, then we need to add the same number to both sides. But how do we know what number to add to both sides? Well, off to the side, we've got to compute the following, right? You take the linear coefficient and you divide that by 2, because that's the second stick. Then you take the second stick and square that number, and that's the number that you need to add to both sides. Now, while you're not required to draw a picture, I think it helps. It can help prevent errors.